Chapter 19, we're going to be talking about the quadratic formula, and it's appropriate that this chapter follows chapter 18, where we talked about completing the square. So the particular type of equation that we were solving from the previous chapter in standard form was the quadratic equation, and it can be written in general as a times x squared plus c equals 0. And so what happens is we keep these variables here, a, b, and c, and they could represent any real number, and we take them and we follow the completing the square procedure. And if we do that and we simplify things along the way, then we can solve for x, and we get this nice neat formula that we can apply to any quadratic formula. And it will give you the real solutions, complex solutions, but there are a few minor details that you need to know before you just start plucking numbers out of a quadratic equation. Alright, so down here, about mid-page, we've had the workbook work out an example using the quadratic formula. And the first thing you may just glance over without paying much attention to is that the equation that we started with is already in standard form. Okay, we have all the variables on one side, 0 on the other, and we can pick out, it's at this point that we can pick out our coefficients a, b, and c. So the first step that you really need to perform when you run into a quadratic equation is to make sure that it's in the standard form. Then you pull out your a, b, and c. A is always the coefficient of the squared term. B is always the coefficient of the linear term, and c is the coefficient or the constant. So we get a is 3, b is -5, and c is 2. Alright, so the quadratic formula is negative b, and so this negative here came from the formula. This negative is just a matter of, it's just a part of b, the coefficient. So we get a minus here, and then we have plus or minus square root of b squared minus 4ac. b is -5. You square both the negative and the 5. Alright, so this first part is always going to be positive, and then this second part inside the radical, minus 4ac, it depends on what the signs of the a and c are. It could be positive or negative. So 4 is a part of the formula, our c is 3, or I'm sorry, our a is 3 and our c is 2. Alright, and then on the bottom, 2 is a part of the formula, it's automatic, and then beside it we have our a. Okay, so it takes a little bit of work to whittle this down to a final acceptable solution, and in some cases we actually keep the radical part. But here we see that on the inside, a -5 squared gives us a 25, a minus gives us a positive 5 here, and 4 times 3 times 2 is 24, and we keep the subtraction. 25 minus 24 gives us a 1 inside the radical, and so what you should see here is this plus or minus, which opens the possibility, and in this case we definitely have two answers. We have a 5 plus 1 over 6, and we have a 5 minus 1 over 6. So with this radical part being 1 is a real number, 5 is a real number. Okay, we can add these together very easily. We get on one hand 5 minus the 1, and then on the other hand we get 5 plus the 1. Alright, and so you take that to the end and simplify. We get 2 answers, and they are 2 real answers, 2/3 and 1. Okay, so some examples to work out on the following page. Example 1, we see that it's already in standard form, so we can say A equals 2, B equals -5, and C equals 4. And so we have the formula x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so this minus is a part of the formula, and we have an additional minus when we insert b, so this is minus minus 5. We bring down our plus or minus and our square root. Inside we have b squared, or in this case a -5 squared. Then we have minus 4, a is 2, and c is another 4. All of that gets divided by 2a, and a is a 2. Okay, we'll work on a piece at a time. One thing we can fix in this next pass is the minus minus. We can just call that a plus 5. Inside the radical, we'll square the b, which is a positive 25. We'll multiply the 4ac, which would be 8 times 4, 32. And there was only one minus associated with these 3 numbers, and so this is going to be a minus 32. And on the bottom we have a 2 times 2, which is 4. (25) minus 32 inside the radical is, let's see, a minus 7. And we still have a 4 on the bottom. And so one more thing that we can remedy here is we can take this negative out from inside the radical and place an I on the outside of the square root. The 7 stays inside the radical, and here we have sort of a final version of our solution. If we wanted to, we could split this apart into 2 different solutions. And with this solution having an I inside of it, these are going to be complex solutions. So on one hand we have 5 plus I square root of 7, and then we could separate the 2 parts on the top, dividing each of them by 4. And then the other solution would be 5 over 4 minus I square root of 7 over 4. So this is, if we wanted to label them, solution number 1 and solution number 2. And they're both complex solutions. Example 2. We have a quadratic equation with this x squared term. And so what we want to do first here is put it in standard form. And I'm going to move this 4x and the minus 1 over to the left, and so that's going to change the signs, because in order to move them I have to subtract the 4x from both sides, and I have to add a 1 to both sides. So sort of 2 things in one step. But over here on the left, or I'm sorry, the right, the 4x and the 1, they disappear and they leave us with a 0. And now back on the left, we have 4x squared minus a 4x plus a 1. And so our A, B, and C are going to be 4. B actually turns out to be negative 4, and C would be a plus 1. So we can't just take the numbers unless it's in standard form. So here are the correct numbers to use with the formula. And so we write x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So with b being negative, we're going to have a minus 4. We bring down our plus or minus. We have a b squared inside, so that would be a negative 4 squared minus 4 times a, which is a positive 4, times c, which is a positive 1. On the bottom, we have a 2a, and so we write 2 times 4. Minus minus 4 is a plus 4. Inside we have a 16 minus a 16 over an 8. And what we see here is that the radical part cancels out. It just turns out to be a 0. So with the 0 there and the plus or minus in front, this cancels out the possibility of having two solutions. We just end up with a 4 over an 8. Okay, plus 0 and minus 0 doesn't affect the solution anymore. So 4 and 8 are all that's left, and we could simplify this as a 1/2. So in the case of where the radical part becomes 0, we just end up with one real solution. One real solution. 1/2. Now for example 3, it's already in standard form. Everything, all the terms are on one side and 0 is on the other. So we can pull out our numbers for A, B, and C, just the way it's written. And one more time through our quadratic formula, we write minus a minus b plus or minus the square root of b squared minus 4ac all over 2a. So we have minus, it's supposed to be negative b. Okay, so just a minus b, and in this case that ends up making this first part of the numerator on top negative. So I guess got a little confused with the last two examples. It seems like every example we've had a minus minus, but in this case we're just going to have one minus because b is actually positive. So inside for b squared we have a 7 squared minus 4a, which is a is 2, and then c is a negative 4. In the denominator we have a 2. This 2 is a part of the formula, and then a itself is 2, so we have 2 times 2. Okay, so in the numerator we have a minus 7 inside the radical. We have a 49, and then with the minus, the subtraction, and the minus from the c, we have a positive, so this is going to be plus 4 times 2 is 8 times 4 is 32. 2 times 2 in the denominator is a 4. 49 plus a 32 is an 81. Alright, so no negative inside the radical part, and so this is a real number, and 81 is actually a perfect square. So we end up with plus or minus 9 divided by 4. And so if we want to separate this into the two different solutions, on one hand we'll have a negative 7 plus 9 over 4. On the other we have a negative 7 minus 9 over 4. Negative 7 plus 9 is a 2. And this works out to be a 1/2. And then minus 7 minus 9 is a negative 16 divided by 4, and we get our second solution. So in this case we end up with two real solutions. There was no I because the radicand of the radical turned out to be positive. So negative 4 and 1/2 are our real solutions. Alright, so one more equation, example 4. Again, we need to move all of the terms, if we're going to use the quadratic formula, all of the terms to the same side. And so to do that, I subtracted 5 from both sides. We're left with a 0 on the right. And here you see that there is no x term, no linear term. And so we say A is 9 and B is 0 and C equals negative 5. So we write negative B plus or minus the square root of B squared minus 4AC over 2A. First part of the numerator is a minus 0. So it's not going to have an effect on our solution. And then inside we have a 0 squared minus 4a and c. So 9 and negative 5. And on the bottom we have 2 times 9. So we can drop the 0, bring down the plus or minus. Inside we have a minus minus from the 4ac, so it's going to be a positive number inside. And let's see, we've got 4 times 5 is 20, times 9 would be 180. And on the bottom we have 2 times 9 is 18. So with this solution, it's kind of tempting to divide 18 into 180 because it'll go evenly, but you can't do that. This 180 is inside the radical. And so we need to simplify the radical first before we carry out any division with the 18. So let's see, what we'll do is we'll go off to the side and prime factor 180. So we've got 2 and we've got 90. 90 will give us a 2 and a 45. 45 will give us a 5 and a 9, and 5 is prime, 2 is prime, and then 9 will give us 2 3s. So this factor tree just simply tells us that we can rewrite this radical as the square root of a 2 squared, since we have 2 2's stemming out of our prime factor tree. We have 2 3's, so we can write it 3 squared, and then we have a single 5 left over. And if you multiply all this together, you'll just simply get back to 180. Now, the square root just simply tells us if we have 2 of any factor inside, we can bring 1 out. So we have two 2's, we can bring a 2 out to the front of the radical. We have two 3's, and so we can bring a single 3 out front of the radical. But then there aren't enough 5's. There's only 1, and we need 2 to bring 1 out. So the 5 gets left inside the radical. The 2 and the 3 that we brought out front will multiply to give us a 6. And so in the end, we end up with a square root of 5 over, and 6 and 18 simplify to give us a 3 in the denominator. So on one hand we have a plus square root of 5 divided by 3, and then on the other we have a minus square root of 5 divided by 3. And there is no I contained in this expression, so these are two real solutions. Two solutions because of the plus and minus, and real solution because there is no I. On the next page, we define what's called the discriminant, and you've already seen it if you've used the quadratic formula. It's simply the b squared minus 4ac from inside the radical. And this part of the formula is what determines how many and what type of solutions that we get from a quadratic equation. And so there's 3 different scenarios that can play out when you're solving a quadratic formula. In this first part, the discriminant is less than 0 is negative. So any negative number for a discriminant results in getting 2 complex solutions. Number 2, and we've sort of seen each one of these in the examples on the previous page. We had an example where the discriminant was negative and we got 2 complex numbers. The second one, if the discriminant turns out to be 0, then we end up with 1 real root. Root is just another word for solution. Okay, a single number, and it's a real number. That happens when you have discriminant equal to 0, and then finally, if the discriminant turns out to be a positive number, and another way of writing that is discriminant b squared minus 4ac is greater than 0. That means it's positive. If that happens, then we have 2 real solutions. So in the next few examples, we'll probably just figure out what kind and how many solutions do we have for a particular quadratic equation. And you can see the workbook solved such an example at the bottom of that page. Definitely try to follow through that one on your own, but I'm just going to go ahead and work out these examples on the next page. And so if you look at the instructions, it says calculate the discriminant, and it says nature of the roots. That's just to say that we want to talk about how many and what type, not necessarily what the numbers or the solutions are exactly. So we still have to pick out our A, which in this case is 1, B is a negative 1, and C is 3. And we still want, while we're reading out these coefficients, we still want our equation to be in standard form. So it was already in standard form. We pick out our coefficients, and now we just focus on this discriminant. Okay, it's the b squared minus 4ac. Do not put a radical in this. We're leaving the radical part out. So b squared is negative 1 squared minus 4. A is 1. C is 3. 4 times 3 is 12. We subtract it. 1 minus 12 is negative 11. And so this means that we ended up with the discriminant, which we say the discriminant is negative 11, and it is less than 0. The discriminant is negative. Okay. Therefore, this particular equation, there are two complex solutions because the discriminant is the inside of the radical. We're taking the square root of a negative number. So we end up with two complex solutions. We only want to calculate b squared minus 4ac. We get a 12 squared minus 4 times 9 times 4. 12 squared is 144, and 4 times 9 times 4 ends up also being a 144. Alright, 144 minus itself is 0. So the discriminant equals 0. Therefore, there are, or I should say is, 1, how many, real, the type, solution. Okay, the next one, sort of one with a little twist to it. We're not told what B is, okay, but we're asked, what does B have to be in order for us to get two real and equal roots? Alright, so first we'll address the 2 and the real part. B squared minus 4ac. If we're to get two real solutions, then this has to be greater than 0. We don't know the b, and so what we do is we plug in a, which is 1, the coefficient of the x squared term, and c equals 9. So we get b squared minus 36 is greater than 0. We move the 36 to the opposite side, and we say b squared is greater than positive 36. At this point, we take the square root of both sides, remembering to put the plus or minus in front of the square root, and we get b is greater than plus or minus 6. Now, so as long as b is greater than plus or minus 6, and in this case, we have to do a little bit of interpretation here. We have to break this up into b has to be greater than positive 6, and if we go with the minus, then we have to flip the inequality and say b is less than a negative 6. Okay? Because this 4ac is a 36, and so if we square, for instance, if we square a negative 5, so I'll go over here and replace b with a negative 5. If we don't flip our inequality and we go with a negative 5, then what we'll be doing is we'll take a smaller number and subtract 36, and we'll end up with a discriminant that is negative, which will give us complex solutions. So with this plus or minus, we have to flip the inequality here. Now, in this case, if we want to address the equal roots part, because with b being greater than 6 or less than -6, we can't end up with equal roots. Okay, so what we need to do is go back and say the discriminant is equal to 0. Okay, we're going to end up with one real number, but it's going to have multiplicity of 2. So with the multiplicity of 2, we can say it has 2 roots, but they end up being equal numbers. It's the same number. So we set this equal to 0. We get b squared minus 4, and the 4ac ends up being the same thing we got initially, 36, except this time we have an equal sign. So we have b squared equals 36, and now if we take the square root of both sides, we end up with plus or minus, which tells us that b has to be equal to a plus or minus 6. So in this case, we have x minus 3 squared or x plus 3 squared, okay, which is how you would factor it if you were to use b equals plus 6 or minus 6 or b equals plus 6. Okay, so in either of these cases, okay, if b was minus 6, this quadratic equation would factor as x minus 3 squared, and we would say x equals 3 with multiplicity of 2. Okay, that means that that solution occurs twice because it's squared. And then the other one, we would end up with x equals -3 as a solution, and again it's squared, so we have multiplicity of 2 here. So you could say that there's 2 roots, but they're both -3. So it's tricky. It's tricky to get the equal roots. So and as far as the equal roots go, that's just sort of FYI. The only thing I'm really going to expect you to do is figure out how to get 2 real roots, not necessarily make them equal. Okay, so if we drop the equal part, I just wanted to mention it because it was in the workbook, but if we strike out the equal part, which number 8 doesn't contain, it just simply wants us to get complex roots, then we go down here and we say for complex roots we have to have a discriminant that is less than 0. Okay, a negative discriminant. And again we have b here, so we want to find the values of b. So we write minus 4, a is 1, and c is also 4. So a equals 1 and c equals 4. We end up with b squared minus 16 less than 0. Move the 16 to the right side of the inequality, and we see that b squared has to be less than 16. Square root of both sides, we end up with b, square root of b squared is a b, is less than plus or minus 4. And so if we go with the plus, then we say b is less than positive 4. If we go with the minus, then we write b is greater than minus 4. Okay, so we'll test these two. just to make sure our inequalities are oriented in the right direction. B less than positive 4, so we could go with the 3. And for A, I want to put in a 1. And C, I want to have a 4. And so this would be 9 minus 16, and I'd end up with a negative 7, which would lead to complex roots for our number, or our solution. So this one checks out. Now we'll test B greater than negative 4. And one such number would be negative 3. Okay. So B greater than negative 4, we would have negative 3 squared, which is a positive 9, and again we would subtract 16 from it, and so we'd end up with a negative 7 again, which is less than 0, so this would lead to complex solutions. So if we were going to graph the possible values of B on a number line, we would have negative 4 with an open dot, 4 positive with an open dot, and only the numbers in between would give us complex solutions. Complex solutions. And we should say B's leading to complex solutions. Alright, on the next page we have a few application problems that we'll work through, and it's going to lead to a quadratic formula. So this first one is in regards to a rectangle, and so we write length and width, and it tells us that our rectangle is 2 inches longer than it is wide. So length is width plus 2. It's 2 inches longer than the width, so we add 2 to the width. And it says our area, so we'll write down the formula for area. Area equals length times width. And then it mentions the perimeter, so we'll write that one down too. Perimeter is 2W plus 2L. So numerically, its area exceeds its perimeter by 11. So area is perimeter plus 11. Okay, and then it tells us to find the dimensions of the rectangle. So we have to sort of join three formulas together. First, since A equals LW, we'll replace the A here in our equation A equals P plus 11 with LW. P will be replaced with this expression, 2W plus 2L plus 11. And now we'll take the fact that L equals W plus 2, and we'll get rid of the L variable in this equation. Okay, with the way it is now, two variables, we can't solve it for one or the other numerically. So we need to cancel one of the variables out, and we'll do that with our expression W plus 2. So L becomes W plus 2. We keep the W beside it. We keep the 2W term on the right. The 2L term becomes 2 times W plus 2. And then we have a plus 11. Okay, so LW replaced A. 2W plus 2P, or 2L, replaced P. And then we replaced L with W plus 2 to get our equation. And so this is the one that we need to solve to find the width. Alright, we get rid of parentheses, we get w squared plus 2w equals 2w plus 2w plus 4. And here I'm just distributing the 2, and I've distributed the w here, getting rid of the parentheses. And so first thing you probably notice is that there's a 2w on both sides of the equation. I'll just go ahead and strike those out. And so we get a w squared on the left. We have a 2w, a second one on the right. And a 4 plus 11 is a 15. And if we take this equation and put it in standard form, moving the 2w and the 15 to the left, they would change signs to a negative 2w and a negative 15 equals 0. So here is our quadratic equation that we're going to have to solve in order to find the width of this rectangle. We will simply apply our quadratic formula, which would give us minus minus 2, negative 2 squared minus 4ac all over 2 times 1, 2 times a. Minus minus 2 becomes a plus 2. Inside the radical we get a 4. For the 4ac part, we have a minus minus, so this becomes plus. And 4 times 15 is 60. 2 times 1 in the denominator is simply a 2. And so we have a 2 plus or minus the square root of 64 divided by 2, which becomes 2 plus or minus 8 over 2. The minus from the plus or minus is going to give us a negative solution, so we'll throw that one away. We don't want a negative solution because that will mean we have a negative dimension for our width. We don't measure things in terms of negative numbers. So we'll just go with the 2 plus 8 divided by 2, which gives us a 10 over 2, which tells us that our width is equal to 5, and therefore our length is 2 plus that, so 5 plus 2, length equals 7. So we have found our dimensions. L equals 7, W equals 5. Okay, example 10, a rocket is fired vertically upward. Its height after t seconds is given by the formula. Alright, so this whole entire notation here, function notation, is the height at a later time. Okay, so this whole h of t is going to be replaced with our 2000. We want to know the time when this rocket is 2,000 feet above the ground. So we're going to replace it with a 2,000. It's a single number. It's not a h and a t. H and t is one single number. So 2,000 equals negative 16t squared plus 800t plus 600. Okay, so solving quadratic equations. First thing we want to do to our equation is move all of the terms to one side. So I'll subtract the 2,000 from both sides. That'll give us a 0 on the left. $600 minus 2,000 is a negative 1,400. And if we want to make our life easier, what we can do is reduce these numbers 16, 800, and 1400 because they're all divisible, let's see, by 4. So I'll go through and divide all the numbers by 4. Doesn't change our solutions, it just simply reduces these coefficients, makes them a little easier to manage. So we get a negative 4 or 200, and let's see, 4 goes into 14 3 times. We get a 200 left over, so that'd give us a 250. And so now we see we could reduce them further by dividing all terms by 2. And so finally we get an A, which is negative 2, a B, which is 100, and a, let's see, a C that's 175. So A equals negative 2, B equals 100, and C equals minus 175. If you wanted to, you could have just went with the bigger numbers, the minus 16, 800, and the minus 1400 for your ABC. You'd end up with the same solution. I just think it's easier to manage these smaller numbers in terms of computing the quadratic formula. Alright, so over to the left, we'll write x equals negative b, which is minus 100, plus or minus the square root of 100 squared minus 4 times a, negative 2, times c, minus 175. Alright, so I'll separate all this so we don't get confused. And all of that needs to be over a 2 times a negative 2. So x is minus 100 plus or minus square root. 100 squared is 10,000. And here we'll pull up our calculator. We have 4 times 2 times 175. And that gives us 1,400, and a minus, minus, minus. We'll keep this subtract sign. And on the bottom we have 2 times a negative 2, which is minus 4. And we'll go ahead and separate the two terms on the top into a minus 100 over a minus 4, plus or minus the radical over a minus 4. The radicand is 10,000 minus 1,400, and so inside we get 8,600. The minus 100 over minus 4 ends up being a 25, and we have plus or minus the square root of 8,600 ends up being approximately 92.7. And that's still over a minus 4. Okay. So I need a little more space here. We have a 25, and this is, let's see, t, I should say, because that's our variable t, equals plus or minus 92.7 over a negative 4. So what we're going to do here is we're going to go with 25 minus 92.7 over a negative 4, and the minus minus is going to give us a positive number to add to the 25. If we had went with the plus, then we'd end up getting a negative number for time, and we don't want that. So we go with the minus, and we get a plus 92.7 divided by 4 is approximately 23.1, and so that gives us 48.1 for our time. And that was the last example of the chapter. If you got any questions, feel free to come by my office. Please get on Alex, get a little more practice with these application problems, and definitely work on memorizing the quadratic formula. Thanks for watching.